Welcome to 11.1 in Algebra 1, simplifying a rational expression, and there are 4 boxes for us to talk about today. So let's dive in right away here. First, we need to understand what is a rational expression. So this term, this phrase, a rational expression, means that we are taking a polynomial, something that we've already studied in this course, and then we're dividing it by another polynomial. So when we have a polynomial divided by a polynomial, we get what's known as a rational expression. So this right here is an example of a rational expression because it can be referred to as a polynomial divided by another polynomial. So that's where we begin our conversation of understanding what even is a rational expression. Box number 2 is going to simplify and state the excluded value. Now, because we're working with a rational expression, that means that there are some values of x such that we could get a 0 in the denominator, and that is never allowed in mathematics, especially at the Algebra 1 level, so we need to exclude that. So here's what I mean. Let's take a look at example A. We're supposed to simplify this, and the way that we simplify this is by simply factoring out the greatest common factor and seeing what can cancel. So from the numerator, x minus 1, there's nothing to factor out except a 1. And in the denominator, I can factor out a 5, leaving me with an x minus 1. Now you can clearly see that this entire term cancels with this entire term. It doesn't really cancel, it just makes a factor of 1. And therefore, all we're left with is a value of 1/5. But the excluded term is, we can only say this provided that we say that x is not equal to the number 1. Because remember, if x was equal to 1 and I plug this back in, I would get a 0 in the denominator, and that would not be allowed. So we would simplify this to 1/5, and we would say the excluded value is x can't be 1. Let's try B. Again, factor everything, so 2n minus 3. In the denominator, let's factor out a 3, and that would leave me with a 2n minus 3. 2n minus 3. And again, you can see this entire term makes a factor of 1 with this entire term. So I'm left with 1/3, and provided we say that n is not equal to a positive 3/2. So where did I get that? I just simply took this part right here, 2n minus 3, set it equal to 0. 2n is 3, n is 3/2, so that's the one thing that n is not allowed to be. Second one down here, again, we've got 26c squared and a 91c. So we are going to factor the greatest common factor out of 26c squared and a 91c. From the numerator, I can take out a 13c. And that would leave me with a 2c plus a 7. And then in the bottom here, I could factor out a... Okay, sorry, I wrote the problem down wrong. This should be 26c cubed, which would leave me with a 26c squared right there. Or 2c squared, and this would obviously be a 2c squared plus 7. Okay, there we go. Again, the whole point of that is to show you that that term can now cancel out. So I'm left with a simplified version of 13c, provided that c is not equal to, I would say the negative. If I take 2c squared plus 7 set it equal to 0, I would get 2c squared is equal to negative 7. So c squared is equal to negative 7/2, and then taking a square root, I can't take the square root of a negative number, so I don't need to worry about any excluded values. There are only imaginary roots that I have to consider. So in this case, I only would say there are no roots for that one. Okay, for box number 3, let's do a more challenging example. Again, the directions want us to simplify and state any excluded values. So again, we're going to simplify the numerator and the denominator and see if anything can cancel. So from the top, I can factor out a 3, and that will leave me with an x minus 2. The denominator, I can factor this quadratic trinomial to x and an x, probably a 2 and a 3. a positive and a negative, and I can see that these individual terms here make a factor of 1. So I'm left with 3 divided by an x plus 3. Provided that x is not equal to negative 3 from this term, but we also have to state the fact that x is not allowed to be a negative 2 from that term. So even though it does cancel out and make a factor of 1, we still call it the excluded term at the very end of the problem, okay? Box number 4 is a tricky example, and I want to bring this to your attention. If I'm trying to simplify x minus 3 divided by a 3 minus x, okay? So if I want to try and simplify this, many students want to just cancel this out because it looks like it's close. But in fact, you can as long as you do one thing first. So if I have x minus 3 divided by 3 minus x, that's the same thing as saying x minus 3 over negative x plus 3. And that's the same thing as saying x minus 3 over negative 1 times an x minus 3. Because when I distribute this back in, notice I would get the exact equivalent statement as this denominator. So when it's all said and done now, this whole thing is equal to a negative 1. So you are allowed to cancel these as long as you realize that this whole entire factor, or this entire expression, has a factor of negative 1 in it. So the answer is left out to be a negative 1. So I want you to try that one on your own and see if you can come up with a simplified version of this guy right here. 4 minus x squared divided by 7x minus 14. Go ahead and try that one on your own. Okay, hopefully you got the right answer. The top is the difference of 2 squares, so it's 2 minus x times 2 plus x. The bottom is factoring out of 7, gives me 7 times x minus 2. I can cancel a 2 minus x and an x minus 2 provided I introduce a negative 1. That leaves me with a 2 plus x over negative 7. Hopefully you got the right answer.